Good evening, Algebra 2 students. We're going to be looking at completing the square tonight. So this is taking a trinomial, a quadratic trinomial that is not a perfect square, and creating a perfect square for convenience sake. We use it to solve quadratic equations, and we use it to look at vertex form of a quadratic equation. So I thought this was a cute little image, but I'm actually just also going to write on it. So if we think about what we're looking at here, you have a value, which say, let's see, count this as, let's see, 1, 2, 3, 4 right there, and this is also 1, 2, 3, 4, and let's call this x, and this x. So this is x plus 4 times x plus 4, which is a perfect square, or yields a perfect square trinomial if I multiply it out. X squared plus 8x plus 16, and you can see the 16 right there. All right, so that is a perfect square trinomial, and we talked about this a little bit in class. The first term is a perfect square, x squared. The third term is a perfect square, positive 16, and the middle term is twice the product, of the square root of that first and last term. So, in other words, one more time, 2 times the square root of x squared is x, and the square root of 16 is 4. 2 times x times 4 is indeed 8x. So this is a perfect square trinomial right here. So let's look at how we create that in a circumstance where it isn't a perfect square. All right, here's the first one. What is the value of c such that x squared minus 16x plus c is a perfect square trinomial? Well, there is a method for finding that value of c. And that method involves taking the b value that we have right here, cutting it in half, and squaring it. And that's how you get that c value. So in this case, negative 16 over 2, the quantity squared, will give you c. So negative 16 over 2 is negative 8, squared gives me 64. So in this case, it's 64 that will make this expression a perfect square trinomial. So it makes sense that we would cut the b value in half, because remember the format for a perfect square trinomial, well actually in this case, it's not an added 2ab, it's a minus 2ab plus b squared. So it's as if the a is in that x position, so we're taking what is left of that term, 2b, okay, in this case minus 2b, we're cutting it in half, and then we're squaring it, and that would indeed give me b squared. So I just want to point out how, based on what we talked about in class with what a perfect square trinomial actually is, this completing the square actually makes total sense, because we're taking that b term, we're cutting out the 2, the double, and then we're squaring it, and that gives us that last term of the perfect square trinomial. All right, so let's look at a couple more of those. What if I had x squared, oh, I forgot to switch it back to a pen. Here, let's make it red. What if I had, oh, I don't like that, hold on. Okay, what if I had this, x squared plus 6x plus question mark? So think about it. What did we say to do? That's right, take b, cut it in half, square it, and we get 3 squared, 9. All right, so that would be that one. How about x squared minus 14x plus question mark? What would that one be? Again, take your b, cut it in half, square it. 49. Okay, and let's do one last one. What if I had x squared plus 5x plus question mark? Oh, that one's ugly, isn't it? Not really. Stick with the same pattern. b, cut it in half, and square it. When you square a fraction, remember you square the top and square the bottom. So 25 fourths. And yes, there are going to be times where you have to deal with fractions here. I know. Oh no, not fractions. We hate fractions. Yes, fractions. You're not going to have a choice. But remember, you'll have a graphing calculator to help you when you're doing the problems in class. All right, now let's actually complete a square and see what we're supposed to do with it. All right, we're going to solve this particular equation, and so we're going to do it by completing the square. The reason we're going to do it by completing the square is that we are not going to be able to factor this easily. For a couple of reasons. One, it may not be factorable. I haven't tried yet. But if I go and I move that 216 over, I have to find factors of negative 216 that add up to 6. Yeah, that's so not happening. So we're not going to do that. Instead, we're going to go ahead and put that 216 back on that other side, and we're going to complete the square. Now, if I'm actually dealing with an equation as opposed to an expression, I still have to do the same thing to both sides. So take your b value, cut it in half, and square it, and we're adding 9. That's right, we're adding 9. Now, if I add 9 to the left, I have to add 9 to the right, okay, which is going to give me a significant number in a moment. We'll look at it. All right, so we add those together. We should get 225. Oh, that looks familiar. I believe 225 might be 15 squared. Let's double check. Siri, what's the square root of 225?
Okay, give me a moment. The answer is 15.
Okay, good. Well, that's convenient because we need a perfect square right there. So then what we do on the left-hand side is we go ahead and actually factor this. Now, if it's now a perfect square, then I can take the square root of x squared and put it in the front, the square root of 9 and put it in the back, and then whatever that sign is of the center term, the linear term, that's the sign here, and it's squared. Okay, so we have x plus 3, the quantity squared, equals 225. Now the next step of completing the square is actually taking the square root of each side of this equation, leaving me x plus 3 on the left, and not the square root of 225, which is 15, but plus or minus the square root of 225, which is 15, plus or minus 15. And then you can finish by subtracting 3. We get x equals negative 3 plus or minus 15. And that gives you your two solutions to the quadratic equation. So negative 3 plus 15 would be 12. Negative 3 minus 15 would be negative 18. And those would have been our factors. Well, those are related to our factors of negative 216 that we would have found in the first place up here. It would have been positive 18 and negative 12. But that yielded us these two solutions in the end. Okay, so completing the square is actually a nice way to do this because you don't need a whole lot of special computation and you didn't have to figure out the factoring. Let's do another one. X squared minus 14x plus 16 equals 0. All right, so we'll do this one too. So let's get rid of that constant. So instead, forgot to switch again. X squared minus 14x, leave a big old space, equals negative 16. All right, now complete the square. So take your b value, cut it in half, and square it, 49. If you add it on the left, you must add it on the right. All right, x minus 7, the quantity squared, is the factored form of that trinomial, and negative 16 plus 49. Let's see, 49 minus 16, so 39, minus 6, 33, positive, no, that can't be right, 39. No, that was totally right, 33. Sorry, a little slow on the uptake tonight. All right, and then what was the next step to solve for x? Square root. Square root. X minus 7 equals plus or minus the square root of 33. So then when we finish it off and add 7, you get x equals 7 plus or minus the square root of 33. And those are your two solutions. And you can leave it in radical form because 33 is not a perfect square. It's not simplifiable. Simplifiable is probably not a word. You can't simplify that radical. You leave it just as is. And those are your two solutions. And you might see it like that. You might see it written out like this. 7 plus or minus, oh no, again, not the plus or minus again. You might see it written out separately. 7 plus the square root of 33. And 7 minus the square root of 33 would be smaller, so we'd actually probably put that first. And then we'd put our little special curly braces around it. Or you could have put them here. I'm just showing off now because I know how to draw them. All right, let's keep going. So as I was saying, is a useful purpose for completing the square is putting a quadratic function into what we call vertex form. So the first one you see is standard form, this one right here with the ABC in it, which is what we see when we're factoring. This one down here is vertex form, and this part is the square that we're going to be completing. Now these are a little bit more challenging, but very, very useful for graphing a quadratic equation without a graphing calculator, and for finding the vertex of a quadratic equation in an easy way rather than, again, using a graphing calculator. So these are important skills for us to have, so let's take a look at one example. And there you see the one we're going to do. It's f of x equals x squared minus 6x plus 7. So instead of using opposite sides of the equal sign, we're going to keep everything on the same side of the equal sign because the opposite side of our equal sign is our f of x. So what you do here is you're going to write the first two terms. You're going to leave a big old space, and then you're going to put in your plus 7. And in that space right there, in that little red line space there, we're going to complete the square, and then we're going to balance it out on the other side. Complete the square in the first space, balance it out in the second. So how do I complete the square with that? Well, negative 6, cut it in half, square it, 9. So we're adding 9. Now to balance it out, outside of where we just completed the square, we have to do the opposite of adding 9, so we have to subtract 9. And that's over there. If you look at this is going to give us our k value right here. K value. All right, k value, and what, there it goes. Okay, so we go ahead and we actually write this in factored form, and then plus 7 minus 9 is minus 2. And now, for our original equation, which was our function, which was f of x equals x squared minus 6x plus 7, we now know what the vertex of that is without graphing it. We know that it is, okay, and this is something that hopefully we discussed in class this last time, the h minus h, so the h here is 3, and then our k value over here, our k value, is the same as the sign we see, so negative 2. hk, okay, that's the vertex of the parabola. So I hope at this point I have succeeded in showing you how the function is related to the equation. Okay, the function is related to the equation, and the way that we use quadratic equations, and we're going to be practicing this quite a bit. Let's go ahead, let's just do one more of those. I know, just one more. I think, as of right now, I think we're at about the 12.5-ish minute mark, so one more of these and we will not go over our usual limit. Hold on. Okay, so like I said, one more, and then I have a funny, and then we'll be done. Alright, so this one is f of x equals 2x squared minus 8x plus 1. So there you can already tell there's a little bit of a difference here. And so again, what we need to do is complete the square, keeping everything on the same side, balancing out. So we start with f of x equals, and we need to take that 2 off, because I can't make a perfect square with a 2x squared, because 2, the number 2, is not a perfect square. So I can't keep that on there. I'm going to take it out. So I'm factoring out, but only of the first two terms. It would leave me x squared and minus 4x. And then I'll leave my space, put my plus 1 back in. Now I want you to take a second and notice that I haven't changed the meaning of any of this. I haven't changed the value, I haven't added or subtracted anything, multiplied or divided anything. All I've done is rearrange by taking the 2 out. And now we're going to complete the square. So we take our b value, cut it in half. Okay, so negative 4, cut it in half, square it. Negative 4 divided by 2, negative 2 squared, positive 4. So we're adding 4 there. And then we've got to balance it out, but I didn't really add 4. Let's take a second and let's look at what I really added. What did I really add when I completed that square? I really added 8. I really added 8. And that's what I have to balance out outside of the parentheses with a minus 8. Alright, so now I have f of x equals, I have my 2, I can factor that perfect square trinomial, again, square root of the first, square root of the last, sign that matches the center, and then plus 1 minus 8 is minus 7. So what are some things we know about this parabola? Well, based on what we talked about in class, we have a situation where it is stretched. That's a stretch. Okay, what we mean by that is that's where it gets narrower. We also know that it opens upward. Okay, opens up because it's a positive 2. And we also know the vertex of the parabola. Right, these are things we would have discussed briefly in class. 2 for x, negative 7 for y. And you have your parabola in vertex form. And remember, just because it doesn't look simplified doesn't mean you can't actually graph this. And you can graph this. You can type it in just like this into your calculator. It gives you the same parabola as that one up top. All right, time for your funny, and then we'll be done. All right, guys. I will see you tomorrow in class.